3I Atlas is an interstellar object that arrived from deep space, bringing with it silent clues about regions far beyond our solar system. From forming a tail in an unexpected direction to displaying physical properties never observed in ordinary comets, this object has forced scientists to ask an extraordinary question. Is 3I Atlas truly a comet, or could it be an ancient time capsule from another star system? Even the way it entered our solar system appears almost impossible to explain. And now, with a major event expected in December 2025, researchers around the world are watching it more closely than ever. Before we go deeper, make sure you subscribe to the channel for more mind-blowing space and science videos. Also, hit the bell icon so you never miss an update, and don't forget to like and share this video to support informative content like this. The journey of 3I Atlas begins on a cold night in July 2025. Across Hawaii, Chile, and South Africa, a global network of telescopes was carrying out its routine task of scanning the sky. This system is known as the Asteroid Terrestrial Impact Last Alert System, or ATLAS. Its primary mission is simple but critical: detect potentially dangerous objects that could threaten Earth. That night, ATLAS detected a faint point of light moving slowly against the background of stars. At first glance, it appeared to be nothing more than a typical asteroid, but when astronomers calculated its motion, they realized something was very wrong, in the most fascinating way possible. In our solar system, objects orbit the Sun at predictable speeds. Earth travels at about 29.8 kilometers per second, Mars at roughly 24 kilometers per second, Venus at 35 kilometers per second, and Mercury, the fastest, moves at about 47.9 kilometers per second. The object detected by ATLAS was moving over 58 kilometers per second. At the time, it was located near the orbit of Jupiter. At that distance, no solar system object should move anywhere near that fast. This extreme velocity could only mean one thing: the object was not bound to the Sun. It had entered our system from interstellar space. Soon after, NASA officially confirmed its status and designated it 3I Atlas. The I stands for interstellar, and the number 3 marks it as only the third interstellar object ever discovered passing through our solar system. Further investigation revealed something even more surprising. Archived telescope data showed that the object had already been observed 2 months earlier, in May 2025. At that time, however, its unusual nature had not yet been recognized. 3I Atlas immediately stood apart from the 2 interstellar visitors discovered before it, Oumuamua in 2017 and 2I Borisov in 2019. The first major difference was size. Oumuamua measured roughly 400 meters in length, while Borisov's nucleus was close to 1 kilometer wide. In contrast, 3I Atlas is estimated to be about 5.6 kilometers across, making it dramatically larger than both. Speed was the second major distinction. 3I Atlas was traveling nearly twice as fast as the earlier interstellar objects. Its trajectory was equally puzzling. Most planets and asteroids orbit the Sun within a flat disk. Both Oumuamua and Borisov entered from above that plane, but 3I Atlas arrived from a steep side angle, so precisely aligned that scientists described it as a rare cosmic coincidence. To trace its origin, researchers essentially rewound its journey through space. Based on its velocity and straight-line path, they concluded that it likely came from a star system near the core of the Milky Way. More specifically, from an ancient region known as the Thick Disk, an area populated with very old stars.
Studies suggest that 3I Atlas may be around 7.6 billion years old, nearly twice the age of Earth. Scientists were able to trace its path back over 10 million years, and astonishingly, during that entire time, it never passed closer to any star than it did to our Sun. When 3I Atlas crossed into our solar system, it behaved unlike any ordinary visitor. While still far beyond Jupiter's orbit, it began forming a cloud of gas known as a coma. At such distances, typical comets remain completely frozen. This early activity revealed that the object contains large amounts of carbon dioxide ice, which can sublimate with very little heat. As it moved inward, it crossed Jupiter's orbit and then Mars's. On October 3, 2025, it made its closest planetary approach, passing near Mars. Cameras aboard orbiters and surface missions captured images of this ancient traveler passing through the Martian sky. Later, on October 29, 2025, 3I Atlas reached its closest point to the Sun, about 1.4 astronomical units away. This was expected to be the peak of its activity. Unfortunately, from Earth's perspective, it passed behind the Sun, making direct observation impossible due to intense solar interference. Yet even before disappearing, it displayed behavior that stunned scientists. Analysis of how sunlight scattered off its coma revealed extreme negative polarization, meaning the light was reflected back toward the Sun. This had never been observed so strongly in any comet or interstellar object before. The chemical makeup of its coma was equally strange. Early observations showed nickel particles with almost no iron, something rarely seen, as the two elements usually form together. Later, iron suddenly appeared as the object heated up, suggesting a structure unlike anything formed in our solar system. Then came one of the most baffling observations of all. When 3I Atlas first entered the solar system, its tail pointed toward the Sun instead of away from it. Although this reversed tail later corrected itself, the cause of this phenomenon remains unexplained. Now, after passing behind the Sun, 3I Atlas is on its way out of our solar system. But before it leaves forever, two critical moments remain. In December 2025, it will reappear from behind the Sun and pass relatively close to Earth. Scientists will carefully study how intense solar heating has altered its surface and composition. Then, on March 16, 2026, it will make a final close pass near Jupiter. During this encounter, NASA's Juno spacecraft will attempt to capture its last detailed images. After that, 3I Atlas will exit our solar system forever, returning to the darkness between the stars, leaving behind more questions than answers.